There we go. All right, so what we're going to talk about is project 9.2 in your textbook. And let me go ahead and give you the page for this so you can, when I refer to it, you'll know what we're talking about here. It begins on page 380. So I'll give you a second to turn to page 380 if you need to. Let me get a marker up. All right, so here's how this is going to work. You're going to download the electronic schematics template file, which is in Blackboard. So actually you don't have to download it as much as just pick on it like we normally do. So this is a prototype drawing. It's created for an electronic schematic template. And so what it has already are some symbols drawn. It has the resistors and the transistors and the capacitors and a few other things. And so you will save that to your home folder and you're going to name it FM Tuner. And then what you're going to do is activate the model tab. You'll draw this in model space. And you're going to draw, then you're going to create two new layers, one called circuit and one called symbols. Now you can see there's a sketch here on your screen, and there's also that same sketch on page 380 at the bottom of the page. These lines that you see in this sketch are the things that will go on the circuit layer, and these symbols that you will see like right here are things that will go on the symbols layer, and you'll have a layer for text that you'll put your text on. So you'll kind of separate this out like you normally do. This will be on multiple layers. Now, if you recall that layering affects blocks, and here's how it affects blocks. If you make a block on layer 0, regardless of which layer you insert it on, it will adapt to that layer if it was made on layer 0. Okay, so if you make it on layer 0, let's say you make a resistor, and the resistors are the things that look like this, and we'll get into those a little bit in just a second. But let's say you make this resistor and you make it on layer 0. When you insert it onto another layer, and let's say that that layer is blue and it's hidden lines assigned to it, then your resistor would come in as blue, and it would also come in as hidden lines. So when you make blocks on layer 0, they adapt to the layer that they're inserted on. Now, if you don't want that to happen, what you want to do is make your blocks on a different layer than 0. For example, if you made all your blocks on the symbols layer, whatever color and line type and line weight and properties that the symbols layer has, that is what those blocks will retain regardless of which layer you put them in on. Okay, so layering does affect blocks, and all that's mentioned in chapter 9 of your book. So let's see if we can get to this guy right here. Okay, so in step 3, it shows you to make some blocks, and I'll go over this in AutoCAD here in a little while. But when you open up that prototype, you're going to see some different things are already drawn for you. And these are some of the symbols that you have. And all you'll need to do is go in and make blocks of each of these and name them correctly. Now, there are a few things we want to look at. And so, for example, there is a block called a transistor. And it looks something like this right here when you see it. And so I'll just sketch one kind of roughly with my mouse right here. But you're going to notice that located right here, there is a circle with an X on it. And what that is, it's not going to be a part of the block. This is something that was placed using a command called point. And what a point is, it's like a piece of construction geometry. And so what we're going to do is that when we make our blocks, we're going to select this point to be our base point. And if you remember, a base point is like a handle that you're using when you move your block around. So the base point is exactly halfway between the end of this arrowhead right here and the end of this line right here. And so that allows us to put this on a line and center it. Let me go back. So your base point, like for example on this transistor right here, would be halfway. It would be right, if we had this line right going through, it would be halfway between there. And you'll see how that works here in just a little while, because like I said, I'm going to get into AutoCAD and show you some things. All right, so what we recommend doing is to begin a line at, well, first off, make circuit your current layer and begin a line at 2, 2.75 and draw that line straight up like this, and you're going to draw these lines 1.25 inches apart. And so what you want is a line that's 1, 2, 3, 4. You need a line that's 5 times 1.125. Okay, that would be the length of that line right there. Once you have that line, you'll use your offset command, and you'll take this line and you'll offset it 1.25, and you'll offset it again and again. So you're going to offset it 1, 2, 3, 4, 5, 6, 7 times. All right. And then draw this line here from endpoint to endpoint, and then you're going to offset it 1.25, and you're going to offset it 1, 2, 3, 4, 5 times. So what you're doing is creating a grid. And the grid, the lines on the grid are 1.125 inches apart. So they're 1 1/8 of an inch apart. Okay. And that's what we're going to use to sort of use as the construction lines to start putting this schematic together. Okay, so let's talk a little bit about the schematic, the symbols that are on the schematic. You have what's called an NPN transistor, and it looks like this right here. There's 3 parts of that. There's an emitter, a collector, and a base. And one of the ways you can use to remember NPN is that the arrow is pointing out away from the base. This is the base right down here, this guy. And so one of the ways that they teach electronics technicians to remember this is they say not pointing in. All right, that helps them. That's a little mnemonic to help you remember an NPN transistor. Now over here we have a PNP transistor, and you'll see that the arrowhead, which is called the emitter, is pointing toward the base right here. This is the collector, and the base would be this line coming off right here. The way they remember this one, they say point in please. Okay, so PNP and NPN. Now that may seem a little corny, but it does work pretty well. So I'm going to jump back to here, and I want you to look at this transistor right here. Now, is that an NPN, not pointing in, or is that a point in please? Well, this is a PNP right here. This transistor here, is that an NPN or a PNP? It is a point in please or not pointing in. Well, it's not pointing in. It's an NPN. All right. And this is an NPN over here. So the orientation of the arrowhead is important. Okay, and you've got to get that right when you draw this schematic, because that would change design intent. So what you may have to do is insert your block for your NPN or your PNP. You may have to rotate that block. You may have to mirror that block to get the arrow into the right position. Now, it's not very difficult to do, but I'm just trying to point out to you that that's what you'll have to pay attention to. All right, the next symbol in this guy is a resistor. And the resistors offer an amount of resistance to the circuit, and it's used by the electrical engineer to direct the flow of current through this schematic. And designers are usually not involved very much in this. Almost always your schematic diagrams are going to be designed by an electrical engineer or electronic engineer. So what you have to do, though, as the drafter is follow the rules for drawing schematics and not change things. Okay, so I want to give you a couple of examples of that. The values for a resistor are given in something called ohms right here. Ohms. Okay, so that's the Greek symbol for omega or ohms, like that. And so whenever you have a resistor, you're going to label it, and you may label it like, if it's the first resistor in your schematic, it may be labeled A1, and then it may say 100 ohms. And that would be the value of the resistance provided by that resistor. If you wrote 10 ohms instead of 100 ohms, you would be changing the circuit. That would be a -5 type mistake. It'd be a very serious mistake on a job because you'd be changing design intent. If it were supposed to be 100 ohms and you wrote 1000 ohms, that would also change the design intent. So it's very important that you pay attention to this. Now, I want to show you something about some of the ways that we abbreviate things. There's a term called a kilo ohm and a mega ohm, and in a kilo ohm it means multiply times 1000. So let's say we have a resistor and it's labeled R2 and it says 2.5 K. All right. That K is very important because that means multiply the 2.5 times 1000. So that would make this 2,500 ohms. And so it's very important that you include that K because it's a multiplier of 1000. But don't just go through and adding Ks everywhere, or mega ohms, because mega ohm is a multiplier times 1 million, for example. All right. So we want to pay attention to, whatever the notation that the electrical engineer has given us or the designer has given us, we want to accurately reproduce that on our drawing. All right, so another type of component that we have in this schematic is a capacitor. All right, and so here's 3 examples of capacitors. The kind of capacitor that we have in this one looks like this guy right here. And you're going to see it has a curve on it, and it has a straight edge, and then it has these 2 leads coming out of it like that. And you'll notice that it's trimmed right there. You need to trim that out. And so sometimes students forget to trim it because when they put it in, they've already got a line drawn, and then they come in here and they add their capacitor like that. You've got to come back in and trim that right there between that, or else I will mark that up as incorrect. The other thing about the capacitor is this one is polarized, which means there's a positive side and there's a negative side to it. The positive side is the straight line that you see right here. And so when you look at the sketch of the schematic on page 380, you're going to see that the capacitors, they're put in there with an orientation, and you need to make sure that you rotate or mirror or whatever you need to do that capacitor to get the orientation correct in the schematic. All right, so this is what you're going to see when you open up the prototype drawing called the FM Tuner schematic, and you're going to make a block for a capacitor. You're going to make a block for what's called a connection dot. You'll make a block for a resistor, for an NPN, and a PNP transistor. And as I was saying, you can see that circle with the X. When you select the parts or the things that you want to be a part of the block, you don't want to select this guy right here. You only want to select that when you're selecting the base point for the capacitor or the dot or the resistor. Okay, so that's why we've put this in here. Now, as I was saying a minute ago, there's actually a command in AutoCAD, and we haven't used it yet, I don't believe, and it's on the draw toolbar, and it allows you to place a point on a drawing. And the point can be changed to look different ways, because really a point is like a target that you're going to snap to. When you snap to a point, you don't use like the endpoint object snap or the tangent or anything like that. When you're snapping to a point, what you have to have on in your object snaps is an object snap called node. All right. So when node is turned on, you can snap to a point like that. And so you'll want to make sure that node is turned on when you start making these blocks. All right. So the book shows you some things you can do to start, laying in those components onto the grid that you've created. And then it shows you the proper way to trim and what needs to be trimmed. And eventually you wind up with this schematic right here. All right. So I want to go over a couple of important things about this. So we have a not pointing in. We have an NPN transistor right here, and it has a label on it, and you're going to use the text command. And what I recommend is using single line text, and I'll get into that in just a second. But I want you to notice that coming out of the base, this line comes over to here, and then there's a dot. And what that dot is called is a connection dot. And what it indicates is that that line is connected electronically to this line that runs north and south here. This line that runs east and west is connected electronically to that. So they are sharing electronic current, all right? But look right here, there is no dot. And what that means is that those lines are not connected electronically. So they are insulated to each other in some way. And it could be that this could be a printed circuit board, and so the conductor could be on one side of the board, and this conductor here could be on the back side of the board, or a different layer, so that they don't touch each other. The moral of that story is don't put a dot right there, or it would indicate that they are connected. So when you draw your schematic, you have to be careful, and if there's supposed to be a dot, you need to be sure that you put a dot there. And if there's not a dot, like right here, don't add one. The other thing about the dots is it's something that you're going to make a block of. And so when you place the dot, you want to place it exactly on the intersection and not like off a little bit. So it needs to be centered right on that intersection. So be careful when you place those dots in there, because if they're eccentric, I will mark them up. Okay, so which means I will mark them in red, and I'll take some points off. So what we have going on here is we have some labels that come in from the left-hand side, and then we have some labels on the right-hand side that appear to be going out from our schematic. And the reason for that is this, and this is pretty common in drawing schematics, is that sometimes you just draw a module for a schematic. And so there's probably another module over here called the first IF amplifier. So that would have its own components. And then there's a module on this side that it hooks up to called the demodulator. So we're just drawing a module here called the FM tuner. Now, the other thing you want to be sure that you put in here is two notes. And one of the notes says that the resistor values are in ohms, and that the capacitor values are in microfarads. So what you see right here, we have a capacitor. The number of that capacitor is called C10. The correct term for that is called a reference designator. The reference designator for a capacitor is C. And then this is capacitor number 10. And below it, we see this 0.1. And what that tells us is that the value of this capacitor right here is 0.1 microfarads, because this note says that all our capacitor values are in microfarads. Okay, now under resistor values, for example, we have a resistor right here. The reference designator for that resistor is R. The number of that resistor in our circuit is number 13. And it says that it is 16K. And so we have a note right here that says resistor values are in ohms, but K means multiply times 1,000. So this is a 16,000 ohm resistor. And you, as the drafter, are responsible for getting that right. Okay? Now, something I want to show you about schematics is this. Like I said, electronics and electrical engineers design these schematics. You won't have to design them if you go to work for somebody. You just have to know how to draw them. So, but here's something when I teach this course, when I teach the course on electronic design and graphics, one simple way to imagine it is that I say, imagine that instead of electronic circuit, this was just a bunch of ropes, and these were knots in the rope. Okay, so where this comes up and ties on to this line right here, any of those three guys, they don't have to be in this particular order because there's no component in between them. They're all tied to the same rope, and there's nothing dividing. There's no resistor in between or anything like that. So the order is not really that important. But when we come down here, imagine that your rope comes in and then you're tying on. Now you're tying on between a resistor and you're tying on between that transistor. You have to tie this one on between these two things right here. If you were to bring this down and tie it on right here, instead of above it like that between there, you would be changing the circuit. So like I said, just kind of imagine that these are ropes in the yard. And so right here you have a rope and you have another rope, and they just cross each other, but there's no knot there. They're not connected to each other. Okay. So that's kind of a simplification of it, but I want to keep it simple here. So let's talk about drawing this in CAD. So I'm going to zoom in here and show you, here's one of those resistors. And so let's say that I have a line drawn, and it's going to be one of my circuit lines, and I go to insert, and I'm going to pick my resistor, and I'm going to drag the resistor in. Pick on that resistor and drag it in like that. Okay, so what you may have to do, you can probably snap to the midpoint or the top or the bottom or something like that. A lot of times what you'll have to do is just snap, because we need this line to be exactly on that vertical line. Then we can pick on this guy, and we can always, with ortho on, which is F8, or we can turn ortho on, and we can just drag it straight down the line. But we need to make sure that ortho is on when we drag this, because let me see if I can move this over and show you. If you put it in the line like that, where it doesn't touch down here or it overlaps up here, that's not the correct placement. All right, so I'm going to undo and get that to go back to where it was. This line here should hit exactly on this line right here. And the reason why that's important is that you're going to come in here and use your trim command, and you're going to have to trim out between all the zigzag lines of that resistor right there. So you don't want to do the trim until you're sure that you have your resistor in the correct place. And so I want to show you something about that. What I've done to try to make my schematic look good is I have lined up my resistors and capacitors. All right, so they're all at the same height in the circuit. And I've lined all of these components up down here. Things will definitely look better if you do that. Like I said, remember to trim inside your capacitors, and be sure that you orient your transistors correctly. So I want to show you about inserting a transistor. So I'm going to pick on insert block, and I'm going to pick, let's see, I want to pick this NPN transistor right here. And you can see when I bring that guy in, it's not pointing in the right direction. So I have the option to come right down here, and I can pick on rotate, and it says select a rotation angle. I'm going to type -90, which should rotate it clockwise. And you see how I rotated that guy and got it in the right spot. So let's say that I put that in. But look at this one here. I need this arrowhead to be on the bottom side, and just spinning it around is not going to do that. what I'll need to do is use the mirror command and pick on that transistor and press enter. And when it says select the first point of the mirror line, pick a line down here and turn F8 on, which is ortho, or come right over here and turn ortho on and pick like that. Oh, looks like I didn't quite finish that command. Pick enter, pick here, and it says erase the source object. I'm going to pick yes. And now you can see that I'm, getting that what you can do, in other words, is if the arrow's not in the right place, you can rotate, you can mirror, north and south or east or west to get them into the correct place. But if they're not oriented as they're shown in the sketch, those would be -5 type mistakes. All right, now the last thing I wanted to show you guys, I think it's the last thing I want to show you, is about putting this text in right here. And I like to use, instead of multi-line text, I like to use single-line text when I do this. And I don't think we've used single-line text yet, so I want to show you about using single-line text. So I'm going to get on my text layer. Let's see, I get on text. And I'm going to go over here to my annotation tab, pick on the down arrow here and pick single line. And here's what happens. It says specify the start point of the text. Well, I would want to pick about where this R begins right here, but I'm going to place it below that. So I'm going to pick right here, and then look at the command line. It says specify the text height. And the text height that we're going to use is 0.125. So we type in 0.125 and press enter. And then it says specify the text rotation. Now, if we wanted the text rotation to rotate and run up and down or north and south, we would type 90 in. But as it is, we just want to label it, horizontally. So we're just going to stay with 0 and press enter. Now, at that point, it wants me to type some text. So I'm going to turn on caps lock, and I'm going to type R12, and then I can press enter, and it'll come down to there, and I can type 6.8 and a capital K. All right, now here's where single line text differs from multi-line text. Whenever you put multi-line text in, you define a window, sort of, and you write inside the window. But here's how single line differs. If I want to put this text in over here, I don't press enter. I just move over here and pick where I want the next text to go. So I'm going to type R14, enter, and 5K. And then if I want to put this one in, I just pick over here, and I can type C11 and 0.01. Now remember, the 0.01 is 0.01 microfarads. Capacitor values are microfarad. So the cool thing about single line text, and then I'm going to enter and enter again, and that's what locks in that text that I just put in there. So the cool thing about using single line text is that when you pick single line and you get your first piece of text defined, you can just keep picking, and you can stay in the single line text command and put all this text in. Unlike when you're in the multi-line text, or if you try to do this with multi-line text, you'll have to draw a window and type your R12 and your 6.8K, and then you'll have to pick enter and actually close that. You can't keep going on. You would have to do it again. Now, what I would do if I were going to do this, I would probably use the copy command, and I would copy that text, and I would put it all over the place, and then go in and double click on it and edit it. At least that would speed things up a little bit. But I would recommend trying single line text as a way to put your text in on this. Okay, so with that done, I think you probably know enough that you can go ahead and draw this. Your notes down here, they're going to be 0.125. Your notes should always match your dimensions or your other text in here. You're just going to write first IF amplifier out here to the side. You may have to move it a little bit to make it look good. And finally, I'm going to click over on Layout tab. So what you might have to do is move your schematic to get it centered inside your border better. And that's not hard to do. Remember, you can double click inside here and get into model space, and then you can window everything right there in model space, and you can use your move command and pick a base point, and you can move your schematic and get it, you know, kind of centered in here. All right, and then you would want to save that and print it from paper space. Okay, now there was one thing I meant to tell you guys, and that was to remind you again that when you snap to a point, and so here's your point command right here. You pick on point, and I'm going to do shift right click mid between 2 points. I'm going to pick here and I'm going to pick here. And what I did is I just placed a point between those two, between the end point of that arrow and this line right here. So I was saying that when you see that point right there, you're just going to pick it as your base point. So when you go to make block and you pick on your block, you would type in NPN transistor, and I probably already have one. And then when you pick on your base point, you want to snap to this guy. And if it doesn't snap, what you need to do is come down here to your object snaps and pick on this down arrow and go select node. All right. So in order to snap to a point, node has to be on. And now I can snap to that node. And so that's just going to be my base point. That's not going to be a part of the block. So when I select objects for the block, I'm going to pick everything, but I'm not going to pick on that node right there. So as we say, don't pick your node, right? So, and then you would enter, and then that would make the block. So the node is used to define the base point for the block. It will not be selected to be a part of your block. So if you hand your drawing in and I can see those points like that, I'm going to mark that off. Now, I do want to show you something about adding these points, because it might come up in a different project or in a different class. When you pick on point and you pick, you see that it makes this little target that you can snap to as long as node is on. But if you go to format and you go to point style right here, you can see that this is selected. The reason I have this kind of a point is under my point style, select with my text style or anything else, I can select a different style and it will change the style of my point. So we have just chosen in this drawing, if you go to point style, we just decided to use this style of point. You have all of these options here as your point. So I'm going to go back to that and you can see that comes back in. So that's how we get the point command to work the way we're using it here in this. And you might want to use it, you know, in the future if you needed to place a point that you needed to snap to. Let's say a bunch of lines were all radiating out of a single point. You could place a point on your screen and snap to it using node. All right, I think that's about it. And so with that, I think I'm going to stop the video